The first quantum revolution was really based in the understanding of quantum physics. And that led to inventions like the transistor and the laser.
So basically what forms today's information technology.
Now in the second quantum revolution, we can control individual quantum systems and we can exploit the properties of those in a new way.
Of course, big words, but I'm sure this will be a second technical revolution.
You probably think it's science fiction, but it's much more science than fiction.
We will see the fruits of the second quantum revolution maybe 20, 30 years from now.
This very counterintuitive fact that electrons can do things, they can be in two places at the same time. There is this cartoon about a skier when you see, and it's downhill from a tree, and you see two tracks from the skis and they go on each side of the tree. And for us that's a funny cartoon, but the electrons would not laugh. I mean, they wouldn't understand what's so funny about it. They do this all the time.
There's four so-called pillars in the second quantum revolution, where you divide things in quantum computing, quantum sensing, quantum communication, and quantum simulation. So those are things where you can do things much better if you have this control of the quantum systems than what you can do with ordinary means.
Because it's so counterintuitive that you can have these enormous amount of possibilities at the same time, and we need to get some intuition for, and we are slowly building that, how to exploit this for practical problems.
We are characterizing our first generation, very small quantum computer.
The goal of the project is to demonstrate a quantum computer with 100 qubits.
And with such a processor, we can address some interesting problems, that a supercomputer could not even address.
Will be an enormous contribution to industry, because it's the same thing that is behind artificial intelligence and self-driving vehicles and the whole Internet of Things.
We have been building competence in superconducting circuits for many years, and for the last 20 years we've also looked at quantum properties of these superconducting circuits. So we have a lot of knowledge. This can really deliver something new. It's not an incremental change, it's really a game changer. It's really a paradigm shift.